Hey, everyone! Today we're diving into one of the most important skills in public health, how to interpret epidemiological data. Whether you're just starting out in research or want to understand health reports better, this beginner's tutorial will guide you through the key concepts and techniques. Epidemiological data is the backbone of public health research and decision-making. But making sense of all those numbers, graphs, and statistical terms can feel overwhelming at first. Don't worry, by the end of this video, you'll have a solid foundation for interpreting epidemiological data with confidence. When interpreting epidemiological data, you'll frequently encounter relative risk and odds ratios. These are crucial for understanding the relationship between an exposure and an outcome, such as the effect of smoking on lung cancer. The narrower the confidence interval, the more precise the estimate. A wide confidence interval suggests more uncertainty in the data. P-values, on the other hand, tell us whether the results we're seeing are likely due to chance. A p-value less than 0.05 is commonly considered statistically significant, meaning there's a strong likelihood that the observed effect is real and not just random noise. Interpreting epidemiological graphs is another essential skill. The most common types of graphs you'll see are line graphs, bar charts, and pie charts. Let's go over how to read them effectively. Line graphs are great for showing trends over time, such as the rise or fall of disease incidence or mortality rates. When interpreting line graphs, pay attention to the x-axis, which usually represents time, and the y-axis, which represents the measure of interest. Bar charts are useful for comparing different groups or categories. For example, you might see a bar chart comparing disease prevalence in different age groups or regions. When reading bar charts, look at the height of the bars to determine the magnitude of difference between categories. Pie charts help us visualize the proportion of a whole that is made up by different categories. For example, a pie chart might show the proportion of deaths caused by different diseases. When interpreting pie charts, pay attention to the size of each slice to understand the relative contribution of each category. Now that we've covered the key concepts, let's put everything together with a quick case study. We'll look at an example report on the incidence of cardiovascular disease in a population and go through the steps to interpret the data. In this report, we see that the incidence of cardiovascular disease is 200 cases per 100,000 people per year. The relative risk for individuals who smoke compared to non-smokers is 3.0, with a 95% confidence interval of 2.5 to 3.5. The p-value is less than 0.001, indicating that this result is statistically significant. So, what does this tell us? First, the incidence rate shows us the overall burden of the disease. The relative risk of 3.0 means that smokers are 3 times more likely to develop cardiovascular disease than non-smokers. The confidence interval is narrow, suggesting a precise estimate, and the statistically significant p-value tells us that the result is unlikely due to chance. And there you have it. Interpreting epidemiological data may seem daunting at first, but by breaking it down into key measures and understanding the tools researchers use, you can make sense of even the most complex reports. Remember to always consider the context, data quality, and statistical significance when drawing conclusions. Thanks for watching. Have questions about interpreting epidemiological data? Drop them in the comments below, and I'll be happy to help.